No? Collins School shut down. They went fully virtual because in the past week, they had 7 cases. Fun stuff. Okay. Here is my plan. In a few moments, just as a heads up, in a few moments, there will be a scheduled assignment on Google Classroom that will go live for you guys. That assignment is out of the textbook, and that is not actually due until Tuesday when I see you next. But I just wanted to give you the heads up that you may be given an alert that, hey, something scheduled went live, and it should be going around 9:30-ish. So we'll see what happens there. Next. What are we doing on Tuesday that I'm so excited for? Yay! Notice the sarcasm in my voice. Benchmarks on Tuesday. So you got to make sure, obviously, those Chromebooks are ready to go. We're going to be knocking out those benchmarks. Again, something that they do expect that you will put forth your best effort on, although it does not count against you in the grade book. Speaking of the grade book, progress reports were due today as I sent out a ton of emails this past week. Did get a good response. So I'm updating things as I go through my emails and the updates that I've been getting, and we'll figure that junk out. Next week, I only see you on Tuesday. Hold on.
Please excuse the interruption. Destiny, Fradiani, and Abby Dorbo, please report to Miss Florey's room. Destiny, Fradiani,
they're in trouble.
And Abby Dorbo, please report to Miss Florey.
So on Tuesday, even if you are online, those people that are joining us online, obviously on Tuesday, we will have to knock out the benchmark. So I will be able to set you up for that, and we'll go from there. So what you missed, there is an assignment that went live a few moments ago. It's out of the textbook that's not due till Tuesday. I see you again on Tuesday. Benchmarks are on Tuesday. I know. I had the same reaction. Yeah, that's where we're at. So to kind of get started with this, I want to review something with you, but I want to review it in the following way. If you do not already have them out, I'm going to need those Chromebooks out and open. I know it's a new one, right? I'm going to need those Chromebooks out and open. I want to review something with you, but in order to review it with you, I need to have some data to see where we're at. So I want to get started with this as soon as possible, especially for the... Yes, but now here's the deal. This one's going to take a little bit longer. Yes. I'm going to strongly suggest that you have a scrap piece of paper. I am going to strongly suggest that you have a scrap piece of paper because some of these problems you are going to have to write out before you select a choice. What you missed, I'll give you the short rundown. Number 1, there's an assignment that it went live out of the textbook.
Everything's due on Tuesday, and then you do quizzes.
Let me do my job.
No, I wanted to do it.
Anyway, it's not due till Tuesday. Tuesday, we have to take the benchmarking class. Yay, excitement. We are doing a quizzes right now, which is just a practice. And then afterwards, I want to review some stuff with you guys. But you need to have scrap paper as you grabbed on the way in order to do some of these problems. Do what you need. Take whatever you need. Yeah. Honestly, take whatever you need. Yes, absolutely. That's what they're there for. Pencils, erasers, paper. Take what you need. Yeah. Oh, yeah. Nothing but the best. No, I really don't know. It's just whatever I ordered. Anyway. So, let me get this thing loaded up on here. Yep, and that assignment.
How's everybody's day going?
No one responds. Oh, well, one person responds. Sorry. Let's see here. Live, classic. There we go. Custom. Boom. There it is. I need everybody logged in. Everybody logged in. For those of you that are in the chat, I know you can't see the code that well, So I am going to type it in. There it is. 788-831. I know it is. As people are logging in. 788-831. I wrote it up top as well, just in case you can't see the chat. I need everybody logged into this. And again, as I've said multiple times, scrap paper is strongly suggested. I'm sorry that fell again. The problems that you are about to see are the types of problems that we did on Wednesday. They are dealing with addition, subtraction, multiplication, division, and the fifth operation, composition. Yes. Now, as you're logging in, there is one thing that I do have to briefly show you, which is a very straightforward thing that you are going to see on this quizzes. Now, what that thing is this. You may see a problem, and I'm going to give it something very basic right here. You may see a problem where they're like, you know what, I'm going to do a very similar thing to what we did last time. I believe it was something like this, where they're going to say, okay, here's f of x, here's g of x. Now, we need you to calculate the following. Look what I just wrote, f of g of 2. Now, that 2 does change things ever so slightly. You can technically do that problem in one of two ways. Number one, you could find f of g of x like we did last class. Actually, I don't even think we used those functions. We used different functions, but whatever, I don't care. It wasn't last class then, but we could find f of g of x like this, and then simply plug in the 2 in order to calculate this thing, which ultimately would give you an 18. Or, because of the nature of f of g of x, the fact that you are taking a function and putting it inside of another function, one simple way of doing this is saying, okay, well, first, what's g of 2? If I have to find g of 2, I just got to plug the 2 in here. 2 plus 1 is 3. Okay. You're doing the problem from the inside out. Where you would do, I'll put it in a different color right here. Put it in green, Christmas colors. Here we go. You're evaluating the g of 2 first by itself. And then once you get a 3, it's just like, oh, well, now I have to do f of 3? Well, yeah, you have to do f of 3. 2 times 3 squared, which is 18. Get you the same answer, obviously, but it's different ways to look at the same thing. If you have a problem with function notation where they're saying to plug a number in, it's just a matter of replacing the variables with that number and evaluating it according to the order of operations. That's the only key difference if you have a number rather than a variable. Okay. How many are logged in? We got 11. Yes. This too? I gave it to you. It was like, hey, evaluate f of g of 2. Where'd the 2 come from? I picked it. You know, the problem will pick it for you. So I'm going to get 6, 7, 8, 9, 10, 11. We have 11 here, and there are 11 logged in, and I have 4 in the chat. Come on with the logins. Who hasn't logged in yet? I'll get you logged in. Even if I click start, there are more people. Even if I click start, the code will still be at the top and you will still be able to log in. So that's actually what I want to do. I'm going to click start. I'm going to get you started. You have your scrap paper ready to go. Here we go. I think it should be Christmas music on this thing. Look, you see is that a reindeer drinking hot cocoa? I don't know. Start. Like I said, for those of you in the chat, the code is at the top of the screen in white. Otherwise, the code is in the chat. Remember? You said last time I told you how it was like F of G, and then you were like, I said they could use other letters.
Yeah, but Q and P didn't.
I know. You ever hear the phrase mind your P's and Q's? That's not where I came from. Have you heard that phrase then?
I have.
It came from the printing press. When they made the printing press, the way that they set it up, they had to set the blocks of letters with inks on them. Then they pulled the thing down, but the letters had to be backwards. So they told the operator to mind your P's and Q's.
Yeah.
Lowercase.
Okay, let's see how it works.
going to give you guys another 2 minutes just to wrap this up. And then there are definitely some problems I would like to talk about. Okay. Shao. Shaho. And let's see where we're at. Come on. Keep going. Excellent. Questions. Boom. Sweet. Let's see what 7 was. And nice. Let's see what 12 was. Perfect. Okay. Ladies and gentlemen, if you would, you can close up those Chromebooks. Don't need them for the time being, but I am going to need those notebooks out and open. There are definitely 2 problems on my mind right now. I'm just taking a quick peek at the other ones. The yellow ones, per se. Ooh, yeah. Those 2 I'll definitely do. Excellent. Click, click, click. Boom. Today is the 18th. And I'm going to call this function operation review. And then before the end of this class period, I hope to show you a little bit more as to what this composition function actually does. The first problem I would like to write down is definitely this one right here. I'm going to write it, and then I'm going to flip my screen back so that you can see exactly what I wrote. And they want to know. There we go. Boom. Flip. There we go. That's the problem I would like you to write down to start. P of x equals 3x plus 4. Q of x equals 2x squared. And they want to know what is Q of P of 2. I'm sorry, negative 2. No, I wrote negative 2. That's what it should be. Now, regardless of how one goes about doing this problem, let's start by just figuring out Q of P of x. Now, to figure out Q of P of x, P of x is on the inside of the problem. P of x is what's being plugged in to the other function. It's literally being substituted inside of the Q of x function. Q of x is like the outer framework. Q of x is supposed to do the following. Now notice I left a blank there. Yes, I left a blank for the Q of x function. Oh, I'm going to move it up because of the glare again. Glare. there. There we go. Hopefully that should fix the glare a little bit, but I left a blank right there for the x because the x is being replaced, is being substituted for. The x in the original q of x is being removed and being replaced with the p of x function. The p of x function is what's going inside of the q. It's really strange. What am I actually going to put in this blank? What am I actually going to put there? I am going to put a 3x plus 4. Now, that's not going to answer the final question, but that is going to get us on the direction towards solving this problem. I got to put the 3x plus 4 in that spot. Now, for the purposes of answering this question, you could simplify that if you wanted to. You could simplify. You can't distribute that exponent. You are not allowed to distribute that exponent. But you could, if you wanted to, do 3x plus 4 times 3x plus 4 and actually multiply that junk out and then distribute the 2. But I'm going to stick with what the question's asking. This is the function q of p of x. And now, this is the function q. I'm going to write it down here. I'll write it down here. This is the function q of p of negative 2. Let me zoom in on that. Wanted to write it a little bit more clearly. Because if they're asking for q of negative 2, I would simply replace that variable with a negative 2. And then what I would be required to do is to follow the order of operations in order to get a correct answer. I got to do what's inside of the parentheses first. I got to do exponents second. And I got to do multiplication third. So 2 times negative 2 squared. Notice my use of parentheses is still there. 3 times negative 2 is negative 6. Plus 4 is negative 2. If I square that negative 2, it becomes a positive 4. Positive 4 times 2 would give me 8.
Mr. Petruzzi, please call the main office. Mr. Petruzzi, call the main office.
Ultimately, this is the input-output way it would look. Q of P of negative 2 is equal to 8. The input is negative 2. The output is positive 8. But this is the justification behind it. Let me flip back to that screen temporarily. Yep, there it is, positive 8. Positive 8. You can see that right there. The other question that came up red in your quizzes was this one right here. Now, I am going to write that down. I am going to write that down and then flip my screen back. Chappelle. Zoom out. Now, they're still talking. I don't know. I don't think they can hear me. Oh, they can hear me now. F of g of x. This was the other red problem on the quizzes that they gave you. Or not that they gave you, but resulted in being a red question because of the incorrect answers. F of g of x. I'm just very interested. What did you guys choose as an answer? Okay. Most of you picked this first one. Oh, I see. Can somebody look at these choices? Do you know why most people chose this first one? what do you think they did in order to get that first one? Again? They just added them together. Yeah, literally. Which, what do you think they did in order to get that first one? Again? They just added them together. Right? Not correct for this problem, but they literally, okay, 2x and then x squared and 3, I'm going to add them all together. That's not what the function asked for. The function did not ask for you to add them all together. The function asked for you to do the composition. And because of that, I have to do the following. In order, they want me to do f of g, meaning g is going on the inside. In terms of the f of x function, which is 2x, versus the g of x function, which is x squared plus 3, since the g of x is going on the inside, I'm just giving you a visual right here. The g of x is making the journey inside of the other function. It's a weird way of putting it. It's a weird way of thinking about it. But because the g of x is on the inside, the g of x is making the journey inside of the f of x function. So it becomes 2 times, well, whatever I'm plugging in this case, x squared plus 3, which to simplify becomes 2x squared plus 6. That would be the resulting answer. Really weird to think it in this fashion, but that's exactly what has happened. Let me just see what choice. Yep, 2x squared plus 6. I was just double checking that thing. I want to go into a little bit more detail as to what a composition function is and how it works. So, for the sake of argument, I'm going to walk away from the quizzes because I definitely want to hit the red questions, and now I can see where we are struggling in certain aspects. And of course, that homework that was just assigned to you today is based on problems that you did on the quizzes. So you will get extra practice with that. But in the meantime, let's do a deep dive on composition. Now with composition functions, I introduced it last class, but let me just do something very basic right here. Let's just say f of x is equal to 2x plus 1, keep it very simple, and let's say g of x is equal to 3x minus 4. I just wanted to use the numbers 1, 2, 3, 4. Give me a number. Sure. Give me a letter, F or G. Which one? G. Check this out. I'm going to show you a little bit of a journey that this number could take. Input. G of x. F of g of x. Check this out. We're going to take that 4, and we're going to shove it inside of the g of x function. If I take that number 4 and I plug it inside of the g of x function, this is really g of 4. What number results by plugging that 4 into the g of x function? Not 4g, because that's the thing. They're not multiplying the two of them together. That's function notation. When I say g of 4, I'm saying take the number of 4 and plug it into the equation that g of x is equal to. What should it be? It should be 8. Because if you look at the g of x function, 3 times x minus 4, you told me to plug in a 4. So 3 times 4 minus 4, which gives you this 8. Which gives you the ordered pair 4, 8. Now I'm taking you on a journey right now. I'm taking you on a journey. It's going to be amazing. Now check this out. I'm going to take that 8 and I'm going to plug it in to the f of x function. I'm sorry, that should be a 4 right there. My bad. I'm going to take that 8 and I'm going to plug it into the f of x function. I could probably just get rid of this part right here. Yeah, I'm just going to get rid of that part right there. What in the world happens when I take that 8 and I now plug it into the f of x function? What do I get back? I do get back 17 because 2 times 8 plus 1. I get back 17, which is the ordered pair 8, 17. This is the general idea of a composition function. I believe that back in Algebra 1, you guys did stuff like this, where it was like maybe X and Y or some junk like that, input, output, and I don't know, maybe you would do like 8 to 4, maybe you would do like I'll do a 1 and a 2 here, so like 1 to 3, and then 2 to 5 or some junk like that, right? Well, that doesn't matter, but I'm just saying, in Algebra 1, you vaguely remember seeing stuff like that? Vaguely. It's been a minute. It's been a minute. I know it's been a minute. My bad. That's creepy. Well, here's my point, though. Watch what's about to happen. She's still looking at her notebook. Watch what's going to happen. Get rid of this y and make this a g of x. Now, watch the journey. 4 goes to 8 in the g of x. Fair? Then, what it actually does is then it might take, I'm going to mess some things up here. Hold on, this would be great. And then, here we go. What the f of x function actually does is it takes this thing on another journey. This is the idea of a composition function. It basically adds an additional one of those circles. I don't even know what you called that. Like an oval type thing? I don't care. Like function mapping or some junk like that. I don't know. They could have called it anything. But here's the point, though. This is what a composition function actually is. It's taking the journey one step farther in a specific order. So it may start at the number 4, where you would do g of 4 to get 8. But then I would ask for f of 8, which brings you to 17. In conclusion of this problem, what they're really saying, is they're saying, okay, well, a composition function basically cuts out the middleman, and I can do something like this. And I would like you to write this down. Look at this. F of g of x. F of g of x, if I were to actually complete this composition, I'm going to have to simplify this junk. Look what I just did there. F of g, meaning g is going on the inside. To simplify this junk, becomes the function 6x minus 7. And what was the original number that you told me to plug in? It was 4, right? I'm going to move it up in a moment. Keep that right there. There we go. Tell me, what's 24 minus 7? 24 minus 7. 24 minus 7? 17. It's just a simple subtraction.
I know I can.
Look what happens with this thing. The original and output thing. Did you ever have, again, I don't know if you actually did this, but in Algebra 1, did you ever do like one-to-one correspondence or something like that? Or say that a function was one-to-one? I have no idea if you did that or not. Did you ever do the vertical line test too? Not for today then. Not for today then. I don't know what you did in Algebra 1. I haven't taught Algebra 1 in like 8 years. I don't care. But everything kind of builds upon Algebra 1. The idea of a composition function is this. Watch this very carefully because this is going to be amazing to you. Watch this. You may vaguely remember mapping these things in Algebra 1. What a composition function does is it says, okay, screw the middle portion. Let's map it directly so that it becomes 4 goes to 1. The 1 goes to the 11. All right, I'm just looking over here. Was it 11 or was it a different number? Yeah, we'll see. Hold on to 12. I believe these numbers may have been off, but it doesn't matter. But the final answer here was 17, right? Okay. Doesn't matter what these other numbers were. But my point being, though, is that it takes out the middleman and it composes the two together. When you compose something, it means you're putting something together. Are you guys familiar with how compost works? You put a bunch of scraps that are a bunch of different things, combination of leaves, food stuff, things of that nature. That is what this thing does. The concept of a composition function, the concept of the mapping of a composition function is to be able to save time when it comes to computing larger equations. If you have one equation that does one thing, that, okay, I have to put the numbers in through here, and then it calculates the money or something from here, and then I have to take that result and plug it in here and figure out the manufacturing cost here, and then I have to plug it in over. Instead of doing that, what programmers would do is they would say, okay, these three equations, let's compose them together so that it saves time and energy. Go ahead. No.
And then number 2, when you do math in your head, can you see all of it? Because before, when you were explaining, you were looking around as you were doing it.
Oh, it was?
Yeah.
Ah.
That's when I do it, I have to close my eyes. So when you see it, how do you
Okay, let's just put it this way. You mentioned your notebook, right? Yeah. Don't take it out. But your notebook might be very organized, and your notebook might be a reflection of how your brain takes in information. Is that fair? Yeah. Cool. When I was in college, in high school, when I took notes, you would never be able to decipher my notebook because my notebook had maybe a basic outline kind of in the middle. But then as I was doing things and as I was adding information and as I was trying things out, my information would go in a lot of different directions and it would literally look like an abstract painting. But to me, it made perfect sense. Yeah. When I do math, it's not that I see things per se, but my eyes tend to dart around because my brain is working in a bunch of different directions all at the same time. It's just the way I'm wired. That's all that it is. You know. Oh, second class in a row. No kidding. Oh, goodness gracious. So, I'm going to try something here. Check this out. We're going to do, yes, that one. So let's just say, for an example that I'm going to put into my notes, let's just say that I had f of x. I'm going to keep it very, very simple, very, very basic here. F of x equals x plus 1. G of x equals 2x. h of x equals x minus 3. I'm keeping it very basic, very simple. I have 3 functions up here. And the idea is that when you put a number inside one of the functions, it performs a different task. One of the functions will add 1, one of the functions will double it, and the other function will subtract 3, depending on what you want to occur. And if there was some combination that they had to go through, this is what we're going to do. So I'm going to pick in order h of f of g of x. I know, right? Now, instead of x, I want to plug in a number. Give me a number. 5, okay. So instead of x, I'm going to put a 5 in there, okay? I'm going to put a 5 right in there. So this 5 has to go on a journey. What function does it hit first? There's only 3 options. It's either the f, the g, or the h. The 5 has to go on a journey. Which function does it hit first? It hits the g first. You work from the inside out. You hit the g of x first. So as a side note, g of 5 is equal to 10 because the g of x function doubled it. Where does the function have to go next? The f. So now you're going to do f of a very particular number. What number? 10. Now f of x is supposed to just add 1, so we get 11. Then finally, the only function that we haven't done yet is the h, which we're going to do h of 11, which subtracts 3. What a composition function basically does is instead of going through that journey, you compose all 3 equations together so that instead of having to do 3 separate calculations, it just basically says, oh, your input's 5? Cool. The output is 8. That's what the composition function actually does. It is. Go ahead. Yes and no. Go ahead.
So technically, we are doing them all together, but I don't know. Actually, I don't know how to do it.
Well, let's just put it this way. Let's say, again, I'm working for like a company, okay? And I know that for the revenue that comes in order for me to actually process the results for somebody for some product that we have, whatever it is, maybe I have to put it through these 3 separate equations. Okay, so the revenue that comes in, I throw it in here, it gets a result. I take that result, I put it in here, it does something else to it, it puts it out here, and etc. Just like these 3 functions do, okay? Now, maybe I have to rerun this revenue calculation multiple times a day. Instead of doing 3 separate calculations multiple times a day, now all of a sudden I'm boiling it down to 1 calculation multiple times a day. Yeah, this is very helpful for people who do programming, because if they can simplify the code that goes into their program can run faster. Mm-hmm.
So it's not something that we would necessarily use, but it's easier.
Oh, you weren't here on the first day of school for my class because you transferred in? Yeah. On the first day of school, I gave everybody an article called Finding the Glory in the Struggle. Okay. Basically, if the question ever comes up like, when are we ever going to need this in real life? That article answers the question on my end, because mathematics is the only course that refines problem-solving skills. And it's not that you'll actually have to do this in life in order to survive. It's that utilizing the refined and exercised problem-solving skills that you gained over the course of your mathematical careers in high school and college, Those will allow you to solve problems in real life. Not these kinds of problems, but your brain will be ready to solve those other kind of life problems. Anyway, that's it for me. I'm going to sign off. Oh, she laughed in the chat. I don't know what she was laughing at, but that's okay. Bell's going to ring. Pay attention to Google Classroom. Benchmarks on Tuesday. Woo!